given problem is solve d cube minus 3d square plus 3d minus 1 into y is equal to sin x plus x cube. Okay, now you observe the order of the derivative is 3. So you can say this problem is belongs to higher order linear differential equation with constant coefficients. Okay, now it is in the form of f of d into y is equal to q of x. F of d into y is equal to q of x. Now the general solution for f of d into y is equal to q of x, we have y of x is equal to complementary function plus particular integral. So now first we have to find out complementary function. To find a complementary function, let y is equal to e to the power of mx be a solution of f of d into y is equal to 0. Then we will have auxiliary equation f of m is equal to 0. So friends, you see, while finding the complementary function, we are taking q of x as 0. So you will get f of d into y equal 0. To get the complementary function, we are introducing y equal to e power mx. Then we will have f of m is equal to 0. Okay. Now, what is f of m here? M cube minus 3m square plus 3 plus 3m minus 1 is equal to 0. So now we have to find out the roots for this third degree polynomial, means cubic polynomial. Okay, now by using the calculator we can do, I know the roots, but if you don't know, you can go for the calculator. You can verify like 1 is a root or not also. Okay, you can do in any method, but I am explaining how to use the calculator in this case. You see friends, here you have a m cube, so go for equation mode. So press 5. Now in the equation we have it is a cubic equation, so ax cube plus bx square plus cx plus d, so plus 4 button. Now here we have to give the coefficients of m cube value, that is 1. Next m square value, m square quotient is minus 3. Next m quotient is 3, and the constant you have minus 1. Now you press is equal to button. You see, we are getting x is equal to 1. Again if you press it, then it is not showing nothing but x is repeated 3 times. X is repeated. How many times means based on the degree. So here m is equal to 1 repeated 3 times because it is a cubic polynomial. So m is equal to 1 comma 1 comma 1. Friends, you observe here the roots are real and repeated. Roots are real and repeated case. Whenever the roots are like a, roots are real and repeated, then we have the complementary function is equal to c1 plus c2x plus c3x square. We need to write like a polynomial expression up to 3 arbitrary constants, okay, into e to the power of ax. If a is repeated, then we are writing e to the power of ax. Now in this case, which is repeated here? 1 is repeated. So our complementary function is c1 plus c2x plus c3x square into e to the power of 1 into x. So this is the complementary function. Now we have to find out the particular integral, right? To find the particular integral for f of d into y is equal to q of x, we have 1 by f of d into q of x. Okay, this is equal to 1 by, what is f of d actually? D cube minus 3d square plus 3d minus 1 into q of x. Q of x is, here we have sum of the two terms, that is sin x plus x cube. You observe this is a sine function, and right side you have a x cube. So whenever q of x is either sine or x cube, sine, cosine, e power ax form and x power m form, we can go for the shortcut method. Yes or no? So now you divide these two, means separate these two. Then here you will have 1 by d cube minus 3d square plus 3d minus 1 into sine x plus 1 by this is d cube minus 3d square plus 3d minus 1 into x cube. Friends, you know that whenever sine function is there in q of x, then we are replacing d square by minus a square. Whenever sine ax is there, we are replacing d square by minus a square. But here in place of a, what I have, ax is equal to x only. So a is equal to 1. So we have to replace minus 1 in this case. Next, you see, I am doing first this part. Later I will do the second part, and then I will add the total particular integral. So this is, I am considering as a pi1. Now 1 by, in place of this is in place of d square minus 1 I have to substitute, but here I have d cube. d cube I can consider as d into d square. Yes or no? So this is minus 1 into d means minus d. Next minus 3 times of d square is nothing but minus 1 plus 3d minus 1 into sine x. Now if you are simplified, then we will have 1 by 1 divided by, you see this is a 3d minus d, nothing but 2d. Next this is minus this is plus 3 minus 1, nothing but plus 2 into sine x. So pi1 you have 1 by 2d plus 2 sine x. So you can take here 2 is a common, then we will have 1 by 2 times of d plus 1 into sine x. Friends, you remember, whenever sine or cosine is there, f of d should contain d square term. If d square term is not there, then suppose 1 by d is there, then you can do integration directly. If it is d is in the numerator, then you can do differentiation directly. But whenever d square is there, then we are replacing with minus a square. Yes or no? But whenever d plus a form is there, then rationalize with d minus a. Okay. Now here you have d plus 1. So we have to rationalize with d minus 1. So d minus 1 by d plus 1 into d minus 1 into sine x. Okay. Now 1 by 2 times of d minus 1 times of, this is a plus b into a minus b. So a square minus b square, nothing but d square minus 1 square is 1 into sine x. Now again d square is there in the denominator, so we have to substitute d square is equal to minus a square, that is minus 1, because in place of sine ax we have sine x. So ax is equal to x, so a is equal to 1. That implies d square is equal to minus 1. Now d minus 1 by d square is equal to minus 1. If I substituted minus 1 into sine x. Okay. Now this is, you have minus 2 and outside you have a 2. So minus 1 by 2 times of 2 is nothing but 4 into d minus 1 into sine x. Now minus 1 by 4 times of, I told you, if d is in the denominator, then you can differentiate directly. So derivative of sine x is cos x, minus 1 into sine x means sine x. So this is particular integral 1. This is the particular integral 1. Now we have to do particular integral 2. I am writing the particular integral 2. We have 1 by d cube minus 3d square plus 3d minus 1 into x to the power of 3 you have. Okay. Now you observe, this q of x is containing polynomial, like it is in the form of x to the power of m. Whenever the shortcut method you can apply, whenever you have x to the power of m and m being a positive integer. Yes, is it like m being a positive integer and x power m form or not? Yes, in this case f of, whenever x to the power of m form is there, then we can apply shortcut method. In the shortcut method, we have to convert this f of d into 1 plus or minus pi of d form, because we can apply binomial expansion. Okay. Now you see, for that we have to take the lowest degree term as a common. So here you have a minus 1. You can take minus 1 is common. Otherwise, we are already done. The roots of this differential equation is, the roots of this polynomial is what actually? D is equal to 1 we are getting. Yes or no? So how many times? 3 times. So this one you can write as d minus 1 whole cube into x cube you can write. D minus 1 whole cube into x cube also you can write. But binomial expansion we can apply for 1 plus x whole to the power of minus n only. So here you can take minus 1 is a common, then you will have minus 1 by 1 minus d into 1 minus d whole cube into x cube. So this one you can write as minus of 1 minus d whole inverse into x cube. Now you observe, this is in the form of 1 minus d whole power minus 3. This is whole power minus 3. Now this is in the form of 1 minus x whole to the power of minus 3. So what is the binomial expansion for 1 minus x whole power minus 3 we have? That is, you see, 1 minus 3x. Minus is there, so 1 plus 3x plus 6x square plus 10x cube and so on we have. Right? Now this expansion is up to infinite, but here how much you can take power, x power, means based on the given q of x. You see here they are given q of x is equal to d cube. So derivative of x cube is equal to 3x square. What is the d square of x cube here? 6x. Next, d cube of x cube is equal to 6. Next, if you are differentiated, that is d power 4 x cube, you are getting 0. For every higher order derivative, you are getting 0 in this case. So maximum you can differentiate the index of 3 only. So d cube term is enough. Higher terms you no need to take. Now you see this one minus of. Now you split this one. In place of x, what I have? D. So 1 plus 3d plus 6d square plus 10d cube. Do you require the d power 4 term? D power 5, d power 6 higher order terms? No need. So close the bracket. So in here you have plus so on. But here up to this only. Into x cube. Now you multiply inside x cube. Then minus of 1 into x cube is x cube minus 3 into derivative of x cube is what you have? 3x square. So 3 times of 3 is 9x square. This is 6 into d square. What is the d square value here? You have d square is equal to d square x cube is equal to 6x. So this is 6 times of 6 is nothing but 36x plus 10d cube plus d cube of x cube is what here? 6. So 60 you are getting. So this is the particular integral 2. Previously we have particular integral 1 is minus 1 by 4 times of cos x minus sin x. Hence friends, this is plus, sorry. Okay, now the particular integral finally we will let pi1 plus pi2. Hence the general solution is y of x is equal to complementary function plus particular integral. Yes or no? Particular integral is pi1 plus pi2. Now the general solution is y of x is equal to, we have previously 1 comma 1 comma 1 are the roots. So c1 plus c2x plus c3x square into e to the power of 1 into x plus particular integral 1 is minus 1 by 4 times of, this is a plus I have written. So this is minus 1 by 4 times of cos x minus sin x. Next pi2 is here you have, pi2 is minus of x cube plus 9x square plus 36x plus 60. Okay, this is the final solution. Is it clear for everyone? Right. Thank you for watching this video.